Welcome back to the deep dive. Today we are narrowing our focus to just one thing, the Kramer CP-AOCH 262.
Which is, for anyone just looking at the name, an HDMI cable.
Right, but it's a very specific one. It's an active, ultra-high-speed cable that is 262 feet long. And the price today is around $768.
Yeah.
So our mission is pretty simple. Why does a single wire cost that much money? What kind of physics is it bending to make that price make sense?
Well, you said it right there. It's physics.
I mean, if you've ever tried running a standard copper HDMI cable even, 50 feet? You know the signal starts to die. You get sparkles, dropouts.
Yeah, it gets ugly fast.
We're talking about more than 5 times that distance. And it's not just holding a signal, it's sending a perfect 8K video signal. That's a whole different ballgame.
It is, and that price really reflects the cost of fighting that signal loss. To push cutting-edge video across 262 feet, you have to maintain an incredible data rate. We're talking up to 48 gigabits per second.
48. Just to put that in perspective for you, your home Wi-Fi, a good one, might move data at 1, maybe 2 gigabits per second.
Exactly. It's a fire hose of information.
So that 48 GBPs, that's the ultra-high-speed part.
Right.
What do you actually get for that huge data pipe?
You get true HDMI 2.1 performance. So that's crystal clear 4K video at 120 frames per second, or, the big one, 8K at 60 frames per second.
Okay, but how do you fit an 8K signal into that pipe over that distance? There has to be a trick.
There are two, actually. First, it relies on something called display stream compression, or DSC. It's an incredibly smart, visually lossless way to package the video data.
So it's kind of like a zip file for the video stream, but one you can't even see?
That's a great way to think about it. And the second trick, for 8K specifically, is it uses 4.2.0 chroma subsampling. It's a tiny trade-off in color information, but it's what ensures the signal stays stable over that huge distance. It's just a necessary compromise.
Got it. So that's the raw data. But for a professional job, you need more than just a picture. You need all the background stuff to work too, right? The compliance.
Oh, absolutely. It handles the whole suite. You get HDCP 2.2 for content protection.
The anti-piracy handshake.
Yep. And for quality, you get high dynamic range, or HDR, and crucially, EARC. That's the Enhanced Audio Return Channel. It guarantees you can send high-quality audio formats like Dolby True HD or DTS HD flawlessly.
So you're not just buying a video feed. You're buying the entire lossless cinema experience from 100 feet away.
Exactly.
Okay, here's what I was really curious about. It says it's an optic hybrid cable. If fiber optics are so good at distance, why isn't it just 100% fiber? Why is there still copper in there?
That's the clever part of the hybrid design. Think of it like this. The fiber optic strands are the massive multi-lane highway carrying all that high-speed video data.
The 48 gigs.
Right. The copper wiring is just the little service road next to it. It only handles the low-speed stuff, things like power and the really important ED-tied handshake.
EDIG. That's the signal that tells the source, like your computer, what the screen at the other end can actually display, right?
You got it. The traffic lights for the video highway.
And this whole high-speed 8K highway is... Wait, the specs say it's only 4.5 millimeters in diameter? That's thinner than a pencil.
Precisely. A pure copper cable capable of this would be like a garden hose, thick, heavy, and impossible to bend. This hybrid design is light and flexible, and because the important signals are traveling as light, you basically eliminate any risk of interference.
You mean like EMI and RFI?
Yeah, electromagnetic and radio frequency interference. In a professional environment with lots of other gear, that's a huge selling point. It's robust.
And for the installers, I saw it's Plenum rated. That's a big deal, isn't it?
It's a critical safety requirement. It means the cable jacket has special fire retardant properties, so it's legal and safe to run through air handling spaces, like in ceilings or walls of commercial buildings. That, plus the gold-plated connectors to stop corrosion, tells you this is built for permanent, mission-critical infrastructure.
So when you boil it all down, who is this actually for?
Well, the takeaway for you is that this kind of cable is the solution when you absolutely cannot compromise. When you need that distance, you need that 8K or 4K 120 hertz resolution, and you need perfect signal integrity. Think broadcast studios, large venues, maybe even high-end medical imaging.
So we've been talking about this 262-foot model, but the source material mentions they go up to 328 feet. That's more than the length of a football field. So here's the thought to leave you with. Just consider the complexity of a world where getting a perfect video signal from one end of a building to another requires a specialized cable that literally sends that signal as a beam of light. That's the real cost and the incredible sophistication behind modern large-scale video.